It's still 0.6 again, but it's still 3 calculations. Let me just run through the calculation on the board then. I tend to always start with the top and the bottom and then do left and right, okay? So we add these up, which comes to what, 7.7? 7.70 times 0.6 times 2. What does that equal? 9.24. Can we stop yakking, please? It's the talking that is the reason we get confused, okay? And then we do the sides, left and right. 3.8 and 3.1 gives us what? 6.90 times 0.6 times 2 equals 8.28. Add those together. 17.52. Again, if we look at it, you can see that we have a positive corner there, positive corner there, and a positive corner there.
I can still don't really work out positive.
Because the measurements are on the inside, yeah, if I was to take 3.1, do you remember going back to the original thing where it was just the 2 measurements? If I was to take 3.1 times 0.6 blah blah blah, I would take it to there. Yeah? And if I was to use that measurement, I would take it to there. So I'm not taking the corner at all. Yeah? If we're doing these measurements, I'm taking that one to there, and this one, to there. So I'm taking it twice. Yeah? You see, you with me now? Okay. So we've got 3 positive corners, and 1, 2, 3, 4, 5, 6, 7 negative corners, which leaves us with 4 negative. So we have to deduct 4 corners again. Deduct 0.6 times 0.6 times 4 equals 1.44 and leaves us with 16.08, yeah? Okay, can we stop talking now, please? This is very complicated. Okay, are we happy with that? Yeah. We all did it, so the last check that we do is just a check that we can project out to turn it into a square, which I saw some of you doing. That was good. So we know that there's 4 corners there. We're happy with that. Okay? So it doesn't matter how complicated the building is. If you can project out, I can take that line to there, I can take that line to there, that line to there, that line to there, so on and so forth. Bam, 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 bam. Turns it square, 4 corners. Yeah? So it doesn't matter how complicated the building is, generally there's 4 corners. There is an exception to the rule which I'll show you, but don't worry about this because you shouldn't have to do it. And then I'll show you how we do turn it into volumes. Okay, with a building like that, it's still 4 corners. I can project that to there, but I've got to add on afterwards an extra calculation for those 2 pieces of foundation there. See it? So that's where it gets a little bit more complicated and turns into four calculations. But don't worry about that, you're not going to be doing it. The width of the foundation is still 600 millimeters. What I've done here is I've added in a new dimension of 900 millimeters deep. Okay? Now then, if you're doing linear, it's just one number. 6 meters, 7 meters, 18 meters. If you're doing areas, there's 2 numbers there. 6 meters by 600 millimetres. 600 metres by 0.6. There's 2 numbers there. If you're doing volume, there's 3 numbers there. 6 metres by 0.6 by 0.9. That turns it into the volume. And it becomes metres cubed. Alright? So where our calculation before was 7.70 times 0.60 times 2, now we have 7.70 times 0.60 times 0.90 times 2. Does that make sense to everybody? That's how you turn it into a volume. Yeah?
Just add the height.
Just add the height or the depth, yeah. Is everybody alright with that? Can I have some nods, please?
Yeah.
For the camera. Sorry. Okay. He made a good point before, because he said, is it in metres or what? I hadn't written any units against the last diagram, so you couldn't say whether it was in metres cubed, or millimetres cubed, or what. Now I'm putting metres on there. So make sure your answer has got the unit written next to it where it says metres cubed. It's not right otherwise. Okay, we've got 5.80, 3.10, 2.80 and 4.90. It's 0.9 deep and 0.6 wide.